Hello. This presentation is on behalf of Doctors Kauthar Abdillah, Boris Aguilar of the Institute for Systems Biology, Cancer Genomics Cloud, Ronald Taylor, National Cancer Institute, and myself, George Acquaah-Mensah, Massachusetts College of Pharmacy and Health Sciences. We present on multi-omics data analysis in the cloud, inference of differential breast cancer-related network hubs between TCGA patient cohorts. So as is well known, breast cancer remains a leading cause of mortality among women. We studied two cohorts, one consisting of Black or African American breast cancer patients at stage 2, 50 years or younger at diagnosis, and the other, white patients of similar age and stage of breast cancer. And our goal here is to characterize these two cohorts and to identify differences in transcriptional regulatory relationships between them using multi-omics data. So we used the Cancer Genome Atlas data in the Institute for Systems Biology Cancer Genomics Cloud, including RNA-seq, microRNA, seq expression, as well as somatic mutation, all in easily queryable combined tables using Google BigQuery. We also used user-defined significant correlations, user-defined SQL queries to identify significant correlations between RNA-seq and microRNA-seq data. So to begin with, we find that there's a difference in prognosis between our two cohorts, that the prognosis for Black or African American patients is significantly poorer than the prognosis for white patients. So regarding the correlations between the microRNA-seq and the RNA-seq data, this here is a depiction of one hub out of several interesting hubs. HES4 happens to be a master regulator, differentially active between the two cohorts, with higher expression in the Black or African American cohort. We find that HES4 is the expression of HES4 is statistically tied to those of several microRNAs, with the edges here, the thicker edges representing higher Pearson correlation coefficients, all edges being statistically significant. So here we uncover novel regulatory relationships between cancer-regulating microRNAs and HES4 as an instance. We also examine the genes that have increased expression in the Black African American cohort relative to the white cohorts. And we find here that those genes have overrepresented among them genes that have to do with proliferation, as well as genes that have to do with the response to stress. We also examine the somatic mutation differences between the two groups. And here we identify certain genes whose mutations occur more frequently among the white cohort than the Black cohort. So CDH1 is E-cadherin, mutations of which tend to result in proteins that have lost their function. We find these mutations occurring more frequently in the white cohort relative to the Black cohort. PIK mutation, 3CA mutations tend to protect against P10 loss. P10 loss is fairly common among neoplasms. So it is interesting that these mutations occur more frequently in the white cohort relative to the black cohort. We also find that there are similarly mutations, genes whose mutations occur more frequently in the black cohort relative to the white cohort. Some of these mutations co-occur, and the co-occurring mutation patterns are distinct between the two cohorts. We find that the frequently mutated genes in the black cohort, such as HY, DIN, HUW1, the E3 ubiquitin ligase, FBXW7 mutations, they co-occur with TTN mutations. TTN mutation types tend to be different between the two cohorts. So this pattern we observe in the black cohort, but not in the white cohort. When we look in the white cohort, there's a different pattern of co-occurrence. We find that CDH1 mutations co-occur with PIK3CA mutations. And this we find in the white cohort, but not in the black cohort. So in sum, we demonstrate here that cloud-based interrogations of breast cancer and related data have tremendous potential. And here we identify novel novel regulatory relationships among genes of interest. And this goes a long way to explain some of the differences in biology that are manifest in the differences in prognosis. Thank you.